Okay, let's now do some transformations with cotangent graphs. Let's change some of the numbers in the equation and see how it affects the graph. So today we're talking about with cotangent, talking about maybe changing the amplitude, the frequency, which will change the period, or having a phase shift. Maybe it's a horizontal phase shift or a vertical phase shift. So in your notes there are 3 examples to follow along with. So again, before we even begin, if this was me, I would have my parent cotangent graph in front of me. So I know when I have a cotangent graph, the normal parent where all the coefficients are 1, the asymptotes are at 0 and 180, and our point is at 90. And we know it's going to be a decreasing function. It's going to go down. All right, so let's look at our first equation. Our first equation says y equals 3 cotangent x. All right, so just like we've been doing, we have 5 things that could be happening here. What is the amplitude here? Ah, I got you. I know what you're saying. You're saying, well, amplitude is 3. Right, but amplitude means what, y'all? Height. And does a cotangent curve have height? No, it goes to positive infinity and negative infinity. So be careful of that. Do not say the amplitude is 3. Cotangent curves have no height. Okay? What is the frequency here? Well, the b value in front of x is 1. If the frequency is 1, we're going to draw one cotangent graph. Well, the frequency affects the period. What is the period for cotangent? It's 180 degrees divided by my frequency. So 180 degrees divided by 1 will stay 180. If the period for cotangent stays 180, that's guaranteeing your asymptote should be at 0 and 180. Your point should be in the middle at 90. Do we have any shifting? Well, a phase shift would be added or subtracted to the angle x. No phase shift. Do we have a vertical shift? That would be a number added or subtracted to the whole function. Nope, there's no number. So all that's happening here is that 3 times whatever the cotangent value is going to make this graph a little bit narrower. But it's going to have the same shape in the same location. So when I go to graph this function, I know my asymptotes are going to stay at 0 and 180. I know my point is going to be at 90 because I had no shifting, I had no changing of the period. So I will do that. Here goes my asymptote, one vertical asymptote. Here goes my second vertical asymptote. All that 3 is going to do is make my curve be a little bit more narrow. So from the bottom, I'm going up and then up. Oh, I lied. I'm not doing tangent. What am I doing? Cotangent. My bad. So I'm not going up. From the left, I'm going down. Down and down. So it should look almost identical if the amplitude, the number in front of cotangent was 1. That's all. It's in the same location. Okay, let's look at our next one. Y equals 2 plus cotangent x. All right? So when I ask you for the amplitude, what are y'all going to say for amplitude of cotangent? Good job. No height. What is the frequency here? Well, it's in front of x. There's a coefficient of 1. So that means our frequency is 1. I'm going to draw one cotangent graph. What is my period? My period for cotangent is 180 divided by 1, which is still 180. That's good. So right now we know our vertical asymptotes are going to be at 0 and 180. Our point's going to be in the middle of 90. Do we have a horizontal shift, a phase shift? Here's my angle x. Nothing's being added or subtracted, so we're not shifting. Everybody's going to stay put. That's what this means. If the period's 180, you are guaranteed to have a vertical asymptote at 0, a point at 90, and the other vertical asymptote at 180. There is no shifting going on at all. Now, do we have a vertical shift? Yes. To this trig function, we have a 2 being added. So we do have a vertical shift. And our vertical shift is plus 2, because there's an invisible plus in front there, which means we're going up. So think about it. Here's the original parent. Instead of this point staying here at 90 degrees 0, it's going to physically shift up 2, 1, 2. So it's going to be at 90 degrees still, but now it's going to be up at the number 2. So let's graph that. All right. So let's put our radians. We got 0, 90, 180. We know our vertical asymptotes are staying put. Vertical asymptotes are staying put. Okay? We have a vertical shift, so we show that by going to the y-axis to 2 and drawing in that new imaginary axis, which we call that axis the sinusoidal axis. I know, it's a funny name, isn't it? So now look, all that tells me to draw a cotangent graph, my point should have been in here at 90 degrees 0. But now it's shifting up 1, 2. So it sits on that new axis. And now I'm ready. From the left, I'm going to go down, 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 all the way to the right. And there is your graph. That's pretty cool, right? Okay. Last one is the tricky one. I want to graph y equals cotangent 2x minus 2 pi. What is the amp? Very good. Even though there's a 1 in front here, there is no amplitude. Cotangent has no height. The only curves that we've seen that have height are sine and cosine, because they go up and then they go down, and then they go up and then they go down, like the roller coaster. So cotangent has no amplitude, no height. What is the frequency now, guys? Oh, there's a change. The frequency is 2. Well, to me, that means in your picture you draw, you should have 2 curves. I know on your homework site, these are all drawn for you already, so you're just picking. So they may have more than 2 curves drawn. I can't control that. If you were doing this on paper, Ms. Black would expect you to draw me 2 cotangent curves. Well, if the frequency is 2, that changes the period. Because the period is 180 divided by the frequency 2, which would be 90. Now, this is important. You need to understand what this means. Normally, on the parent graph for cotangent, the asymptotes are 180 degrees apart. From 0 to 180 is 180 degrees. If the period is 90, now you're saying they're only 90 degrees apart. So the vert asymptote is at 0. But now you're saying the second asymptote won't be at 180. The second asymptote would only be at 90, which means the point would be in the middle. And halfway between the 0 and 90 is 45 degrees. So that's what I want you to understand what's happening here. When you're graphing a normal cotangent, the period's 180 means there's 180 degrees between the 2 vertical asymptotes. Now you're changing the period to 90, which means there's only 90 degrees between the 2 asymptotes. The first asymptote for cotangent begins at 0, but the second one can only be 90 degrees away. That's what puts it at 90, so halfway would be the point at 45. Okay, we all good with that? All right. Do we have a phase shift? Remember, a phase shift is a horizontal shift going left and right. Well, going left and right is on the x-axis, which has to do with the angles, because the x-axis is measured in angle measurements, radians. Well, sure enough, we do have a phase shift. There is a number, 2 pi, being subtracted from our angle. But what did we learn way back when we were graphing sine and cosine? To tell the phase shift, your coefficient for your angle has to be the number 1. What's the number right now in front of our angle? 2. How do we get it out of there? We use our factoring skills, our GCFs. We're going to factor out of here a 2 and rewrite this. So if I rewrite this expression, it would be y equals cotangent. I'm going to pull out the 2. And now that's going to leave me x minus pi. You all have to agree those 2 statements mean the same thing. I still have a frequency of 2, but now I can tell the phase shift. The phase shift is minus pi. Now, what does that mean? The minus means instead of going to the left, we're going to go in the opposite direction. This means to move the whole graph to the right 180 degrees. So now, guys, think about this. Normally, when you draw a cotangent, the first asymptote should start at 0 degrees. But we're not going to start at 0 degrees because we're going to move everything to the right 180 degrees. So we're going to have to add 180 here. So if we add 180, add 180, add 180, that means our vertical asymptote is going to be at 180, our point is going to be at 225 degrees, and our other vertical asymptote is going to be at 270 degrees. Y'all with me? All right, let's draw that. Okay, let me get a big XY axis. Okay, this looks much better on graph paper. Okay, I'm just drawing it freehand, but you should really be using graph paper. So, when we graph cotangent, we don't need to set up the y-axis at all because there's no height, there's no amplitude. We don't have to worry about that. We do have to set up the x-axis. We got to set it up with 180, 225, and 270. Now, everybody look at me. I'm going to put the blue lines in. Here is 0. 180 to 225 is going up in an increment of 45 degrees. 225 to 270 is going up in an increment of 45 degrees. So what you're doing is you're going to label in increments of 45. So everybody look at me. Here's my graph paper. The first blue line is 45. That would be 90. That would be 135. That would be 180. So this is where my 180 is going. Every blue line is representing 45 degrees. That's 180. This would be 225. Now I know what you're thinking. Oh gosh, I got to convert that to radians doing the conversion. No, just think. 45 degrees is 1 pi over 4. So this would be 2 pi over 4, 3 pi over 4, 4 over 4, which is 1. So 225 is 5 pi over 4. 270 is 6 over 4, but that reduces to 3 pi over 2. Make sense? So now we know we're going to put our asymptote at 180 and our asymptote at 270. We had no shifting up or down. There's no number being added or subtracted to the whole trig function. So we now know at 225 the point sits on the x-axis. We know because it's totangent, it starts at the left and goes down. It's decreasing. Now, if I'm doing this on paper, you're not finished yet because your frequency was what, everybody? 2. So I only have one cotangent, so I have to draw another one. So this was at 270. We're going in increments of 45. So the next line, 270 and 45 is 315. If this is 4 over 4, 5 over 4, 6 over 4, this is 7 over 4. The next line would be 8 over 4, but 8 over 4 is 2 pi. So here goes the next asymptote at 2 pi. Here's where my point goes at 7 pi over 4, which is 315 degrees. And there goes my next cotangent curve. Voila, we are done. I hope you enjoyed that. We have 2 trig functions left to look at the next video.